Hello, this is Maths 113 Calculus. We're having a look today at Chapter 4 and Question 11. So this involves what is called implicit differentiation, is the fancy name for it, implicit differentiation. So in this question we're given a curve implicitly defined. Now it's hard to draw this curve, we wouldn't expect you to be able to draw it. If you're playing with Maple, you might like to get Maple to draw this. It's actually a very interesting curve, but I won't draw it here. I'll leave you to play with Maple and get a picture of it. All we want to do is we want to find the equation of the tangent to the curve at the point 1, 2. So we want the equation of the tangent. Now to get that, we're going to have to take the derivative of both sides of this. Now implicit differentiation is not complicated, but you have to think about it in the right way. So I'm going to take my curve and I'm going to take the derivative of both sides of this with respect to x. I might take the brackets out here, so this is the derivative with respect to x of 3x plus 3y. And I'm going to work out the derivative of this and try and get dy dx. So I differentiate both sides with respect to x. Now one little useful hint, it's a little bit trite I suppose, but one thing that might help you to remember this, whenever I do these, or certainly when I was learning them, I used to put little brackets around the y to remind me that I'm going to need to multiply by the derivative of the inside of the brackets. What I mean by that is, if you go back to your basic maths from school, if I give you something like x cubed plus x all to the fourth, and I say work out the derivative of that, then you bring the power down the front, you copy all that down, and then you decrease it by 1, and then you multiply by the derivative of the inside. Yep, so that was just the chain rule. And we're going to do a similar thing with these. Put little brackets around the y, and you remember that you're going to differentiate this just like you did before, but you're going to multiply by the derivative of the inside. And that way you won't miss the y dash term that's going to appear. So you differentiate x cubed, you get 3x squared. Now I differentiate the y cubed. By the chain rule, you bring the power down the front, decrease it by 1, but you must multiply by the derivative of the inside of these little bracket with respect to x. And that we write symbolically as dy dx. On the other side, I can differentiate 3x with respect to x, that's 3. I differentiate 3y, well that's 3 times the derivative of the inside, which is dy dx. So that's called implicit differentiation. The function's given not explicitly in terms of y, but implicitly, and I'm going to differentiate that implicit expression. Now the name of the game, of course, is to get dy dx by itself. So I have a dy dx term there, and I've got a dy dx term there. So I'm going to bring those together, and I'll write this as dy dx. I've got 3y squared there. Pull that on the other side, I get minus 3, and I'll take all the other terms on the other side, so I get 3 minus 3x squared. Finally, to get the derivative dy dx, I just divide, so I get dy dx equals, and I notice that I've got 3's everywhere here, so I may as well divide out by the 3, so I get 1 minus x squared divided by y squared minus 1. So there's a formula for the derivative at any point. And now I work that out at the point, well, that's going to be 0 at the point P. Because at the point P, x is 1, so 1 squared minus 1 will give me 0, and the bottom's not 0. So that if the derivative is 0 at that point, then, so the equation of the tangent is going to be y minus y1, that's y minus 2 is m, which is 0 times x minus x1. And so the equation of the tangent is y minus 2 is 0, or y equals 2. So in fact, the tangent is parallel to the x-axis at this particular point. And so that solves the problem.